Okay, so the next problem in the lead code we are solving is minimum genetic mutation. Okay, so basically, let's not go into biology like gene and all this thing. Let's see the problem. Okay, so basically here they have given a string here. Okay, this is one string and this is the final string. Okay, we need to modify this string from this to this one. Okay, and also like there are being given some condition like based on how we are going to traverse from here to this one. Okay, so what are those condition? The condition number one is we are allowed to build new node only using ATGC character. So meaning, let's say that here this is the start string and this is the end string, right? And I can make some changes to this string to get this one, correct? That's how I'm going to solve this problem, right? So I cannot replace C with D. Okay, I need to use only these characters, ATGC. Okay, we need to use only that character. That is condition number one. And the second condition is, let's say that I'm going to replace this one, A to C. Okay, so it will, how it will look, ACC something like that. Okay, but I need to know if it's a valid or not. Okay, so to check if it is a valid or not, they have given a bank, like I mean it will be list of genes, a list of strings. Okay, whatever the combination I build, it should be there in the bank, or else it's not a valid. We are not going to take that combination path. Okay, so that is one condition. We are going to use only ATGC character to build a new combination, and we are no, like I mean we are allowed to replace only one character at a time. Okay, and the node next thing is yeah, and also this one is we should be in the bank. These are the three conditions that we are going to use to build a new combination, and whatever the combination that we get, we'll again apply the same law, same rules on that condition to get a new combination, right? It's like building a path. Okay, so like to simplify, right, what's happening here is here given the start. Okay, we are given the start in and we have been asked to the end. Okay, and now let's say that there can be numerous ways to go here, right? Let's say that I can go in this path maybe, and maybe there may be some shortcut. Okay, and also like this, like I mean it's like I mean we don't know, like I mean there can be a numerous of ways like going from start to end. And ultimately what is being asked here is what is the minimum number of steps that it takes to go from start to end while ensuring the required conditions are met. Okay, so now let's see how we, let's say that we here, right, we are given the start, we are also got the end. But if we know the end nodes, right, it would have been easy for us, because let's say that in the case of graph, right, how it will be like, let's say that we have this four nodes and we need to traverse from, this is the A node and this is the B node. Okay, we need to traverse from A to B. Okay, and let's say let's connect it this way. Okay, let's connect it this way. And like what would be the steps required to go here? I can go from here also, right? I can go in this direction, or I can simply take this path one, right? So this will make us, this will give us the minimum number of steps as two, correct? And correct number of two. Okay, and as this is, it's not even a weighted graph. Okay, so yeah, now how are we going to solve this problem, like this kind of problems? Like I mean if it was a weighted graph, right, we could have used the Dijkstra's algorithm. But if it, as it is not a weighted graph, right, the one of the easy, like I mean easy and efficient algorithm would for the minimum pass would be the BFS. Okay, so in this problem we are going to solve it via BFS. Okay, and even to apply the BFS we need the nodes here, correct? We need the nodes, but we don't even have the nodes. So we are going to calculate this nodes on the fly. Okay, so now let's see how are we going to do it. Okay, so let me clear this off first. Okay, so yeah, like I'm taking this as an example. Okay, this is the same case for 8 or whatever it is, 8 length, right? Doesn't matter, but we just need to understand the logic here. So this is TGCA and this is TGAC. This is what we need to get. Okay, so now what we need to do is we need to at once we need to apply some condition here, right? We need to modify, replace the characters with any of these characters. Okay, ATGC, and we need to replace only once at once, like I mean one character at once, and then we need to make sure that if it is present in a bank or not. Okay, so let's say like at first what we need to do is like we can apply BFS, but to apply the BFS we need to know what are the next possible nodes. If I know these nodes, right, I can just go traversal and get the value, get to the end, right, and calculate the minimum number of steps required. So like what we are going to do is next possibility is it can be like these are four characters, right? Like I mean, and also we can modify only one at once. We can at least get a four possibilities, right? We can get four possibilities here. Basically, let's say that if I'm going to modify, mm let's say that, or not actually 16, I believe 16 possibilities we are going to get, because if I take this one, right, I can modify this one as A, G, C, A, right? And next I can modify the first string itself as T. I'll pick the this time T. Okay, T, G, C, A, like yeah, this is the same one, but let it be there. Okay, and I will have to replace with the G. So G, G, C, A, G, It is getting slow here to write. So let me just skip this. Okay, CGCA. Let me just write the last combination. Okay, if I just replace this one, right, the first character, I'm going to get the four possibilities. Even similarly, if I do this one for this one, right, I might get a four, few more, and for this one, four, right. Ultimately, I might get 4, 8, 12, 16 combinations. Okay, so now out of this 16 combination, like I mean from here, it means that TGCA can go to 16 number of nodes. Correct, like from there it can take any number of direction. What it means is it can go to the 16 number of nodes. Okay, and now to simplify it here, we cannot go to what we can do here is, it has been said that like we have given the bank actually valid number of strings. Okay, let's say that this is not in the valid bank. Okay, this is not in a valid path, so we are not going to consider it. So now it is only the 15 paths. So and also the bank can have any number of is, there is no restriction as such. So like I mean, to understand here, what we are going to do here is, like we have been given a string, we will be building all the combinations, and then we'll check if it is present in the bank or not. If it is not present in the bank, we are not going to consider it. If it is present, it means that we got a node for next for the traversal. So we have got a 15 nodes, and for each 15 nodes we are going to do the same thing. Okay, now let's see how we are going to approach this problem in the code. Okay, let's see how the code looks, right. So basically we'll be using the breadth first search here to solve this problem. Okay, like the algorithm is will be similar. I'm not going to explain the BFS here, but let's see how it can be solved. Okay, first thing is we have need to search every time. We need to search in the bank if it exists or not. Correct, looking for a element in a list will be slower compared to the set. Like I mean, set will be little, it will be faster actually. So as it stores the hash values and those things, right. So it will be ideally faster, set will be faster. Okay, so we are going to convert the list to the set one to make our operation faster. And let's say that if end result is not at all present in the bank, right, it's not a valid thing, right. Why do we have a bank? Like bank consists of the valid strings, but end is itself is not a valid. Sorry, got disconnected. Okay, so let's say that he converted this to the set, right, like operation will be faster. So now the next thing is, like say that the bank says what is this bank for, to say that what are the valid combinations, right. So if the end result is not in the bank, we can simply return as -1, right. Like I mean, no need to calculate further, because however we are not going to reach the end, right. That is one thing. So now how are we going to, as we know in the BFS, what we'll do is we'll start adding the element to the queue first. Okay, we'll add the queue and we'll explore it, right. Let's say that if I want to explain here quickly about BFS. So what the BFS, what we'll do is we'll explore one node and we'll add it to the queue. Okay, once we're done with the exploring this node, we'll add all the adjacent nodes to the queue. Correct, let's say we'll add 1 2 3 1 to 15, we'll add all everything to the 15. And what will the next thing what we need to do here is, once we are done with, once we add all these 15 to the queue, I mean we got these nodes, right, we'll have to explore this one, next one. Correct, we'll have to apply the same combination on this string. So that's what we are going to do here. Like we have added 150 1 to 15, right. Once we pop this out, we are going to build a combination and we are going to add it at the end, right. So similarly, that's what going to use it in a BFS. So initially we initialize the queue here and we'll say it is already visited. Okay, and finally what we are going to do here is, and also we need to keep a track of level, right. Like I mean, by using this level we can identify like how many number of steps that we took to reach to the that node. Like once we pop that node, and if we found that okay, this is the node that we are looking for, we can simply read this value, so that so that it will be clear for us, right. Like I mean, okay, this is the number of steps that it took from start to end. Okay, so now what we are going to do is we initialize this queue. Okay, and now we are going to build the combination. I think this is the only change that is here with respect to BFS. If we are already good with the BFS, right, then it's, I think it's a straightforward problem here. So how are we going to build a combination? So we have a 8 characters in a string. Correct, so that's why we are going to start from index. I think you can simply say length of the start chain instead of this one, right. We can simply say length of the start chain, so that it will be applicable if the problem statement changes to some other, right, it will also work. Okay, so we'll get for each of the character, like I mean, if out of this one, we'll be modifying each of the character. Basically that's what that for loop is for. We'll pick this character first and then this and then this. Okay, and for each of the character we'll replace with ADGC. We'll pick A, we'll pick T, we'll pick G, C, right. After that we'll be replacing it with this. Okay, and as we know, like strings are immutable, right. So we cannot simply say we can update the string by the index. So let's say that this is the string, right. Let's say I cannot update let's say that the string is attached to char is equal to atgc. Okay, I cannot say char of 0 is equal to b, right? That's not doesn't work. So that's why we'll have to make it this way. We'll have to we use string splitting and concatenate at the end. Okay, so now this is the logic to build the combination. Once we have done building the combination, we'll check, okay, this is the combination, this is the only till. Okay, and we'll check if it is a valid, like I mean if it is in the bank. Okay, and if it is not visited, like I mean as we know, we are not supposed to visit the node again and again, right, in the BFS. So we'll check if it is not visited. Ultimately, what let's say that we found a string, and if it is that itself is equal to an engine, right, we can simply return this one. Okay, we found a result, we can just return whatever. So far whatever we calculated, will also we can add this current level also. So ultimately answer will be level plus one. If it is valid and it is not found, right, we can add it to the queue so that we can process it and we can proceed further. And if we couldn't find it, we'll ultimately can return it as minus one. Yeah, that's it. Thanks. Yeah, I would like to quickly summarize what we have done so far. So basically, there was a start node, there was an end node. It was being given the start string and end string. We need to modify some characters in this one, like they're given character ATGC, and we need to get here. Okay, and so as we have a start node, as we have a end node, and they're asking for a minimum number of steps, we decided to use a BFS here, right? Not the Dijkstra's, because it's a unweighted graph. Okay, we and now we know the start node, we know the end node, but we don't know how to go it there. But they have given us some condition how to go there, right? Like what will be the next possible strings, right? They have given the condition. We are going to build the string, and we'll check if the string is valid by checking it in the bank. If it is a valid, we'll consider it as a path, we'll add it to the queue basically, and then we'll build the new string again out of that. Finally we'll be reaching that node, right? Like it can be a number of ways. Ultimately, like whichever the node that we will be reaching the first, right, that will be considered as a minimum steps. That will be, we will be returning the level for it. That's it. Thanks.